Dear student, I am going to discuss the question number 6 of paper number 2 of JEE Advanced 2015. In a given question, the electron in a state of lithium plus 2 ion and the angular momentum is given by 3h upon 2 pi. And we have to calculate the wavelength of de Broglie wavelength related with this excited electron. How we can calculate? As we know that angular momentum is given by L is equal to nh upon 2 pi, and this is equal to, according to question, 2 pi, so that we can write n is equal to 3. It means n is equal to 3. It means, suppose that we draw the wave format of this is given by like this. This is the wavelength lambda. Okay, and the complete part is equal to 3 lambda. As we know that the length of orbit is given by length of orbit 2 pi rn. The rn means radius of nth orbit, so that 2 pi rn means a naught bear by z, and it is equal to L naught means 3 lambda. Here n is equal to 3 and z is equal to also 3. So put the n is equal to 3 lambda is equal to 2 pi a naught 3 square by 3. It means lambda is equal to 2 pi a naught. So from this equation we will compare this, so that integer will be equal to p is equal to 2. So that answer will be equal to 2. Thank you. Dear student, I am going to discuss the question number 7 of paper number 2 JEE Advanced 2015. In this question, we given a situation with the mass capital M and the two masses small m connected by the massless rod. Okay. Now, we have to calculate the relation between small m and capital M when the tension in the rod becomes 0. This is the actual question. In this situation, the tension in the rod will be 0 if relative acceleration between the two particles will be 0. It means both move with the same acceleration. How we can conclude from this? Both have same acceleration on the both particle will be equal. Okay. So one by one we will calculate net force on A and net force on B and then equate that. Okay. So that F on A is given by, you have to calculate this force on this particle, attraction by this, attraction by this, it means minus sign. G capital M small m, this is the 3L, it means whole square, minus G m square upon L square. We are taking the minus sign here because in this direction force exerted by this and exerted by this will be in this direction, so minus sign. Now force on B is given by G capital M small m 4 L whole square plus GM square upon L square. Now according to situation, say FA is equal to FB. GM small m upon 9L square minus GM square upon L square. G capital M small m upon 16L square plus GM upon square upon L square. So that by solving this we can write capital M 1 by 9 minus 1 by 16 is equal to 2 times of M. L square cancel out. Okay. Capital M 7 upon 144 is equal to 2M, and M is given by 7 capital M upon 288. So that N will be equal to 7. So that final answer will be equal to 7. Thank you. Dear student, I am going to discuss the question number 8 of paper number 2, JEE Advanced 2015. In this question, we have a function of energy of any system is given by E is equal to A square e raised to power minus alpha t. We are given a percentage error in A as well as we are given a percentage error in time at a certain given of instant. And we have to calculate the percentage error in E. Just we are taking the log from both sides so that we can write log E is equal to twice log of A minus alpha t. Okay. Now differentiate this equation. 1 by E, it means this is the ln. Differentiate this equation. dE by E is equal to twice of dA by A minus alpha dt. This is given 1.25%, but we have to calculate this part. How we can calculate? We are doing extra calculation in this. We are given a dt by t is equal to 1.5%. Okay, and at the certain time t is equal to 5 seconds, and this t is given by 1.5 into 5. It means 7.5%. Now 25 error plus sign. Okay, this is 0.2 and this is 7, so that we can write 2.5 plus 1.5 is equal to 4%. So percentage error in E given by this. The answer will be 4. Thank you.
Good morning, students. We will discuss question number 9 of paper 2 code 5. In this question, we have been given that there is a parallel plate capacitor of plate area S and the separation between the plates is D, and initial capacitance will be equals to C1 epsilon 0 S upon D, because here initially the medium between the plates is air, but later on there are the two different dielectrics of relative permittivities. Epsilon 1 is equal to 2 and epsilon 2 is equal to 4 has been introduced as shown in the figure. And now we have to calculate the new capacitance, and finally we have to calculate the ratio between the initial capacitance and the final capacitance. So in the second case, when we are introducing the two different dielectrics of relative permittivities, epsilon 1 is equal to 2 and epsilon 2 is equal to 4, the capacitance will be having the arrangement. In the case number 2, this C2 can be written as, here I will just make the diagram in this way. There are the two capacitance in the series combination and here in the parallel with the next capacitance here. So if we will draw the diagram here, this, let us say this is CP capacitance, this is my CQ and this is my CR. So I want to calculate this C2. So what will be the value of C2 here? These are in the series combination with the parallel combination with the capacitance CR. So it can be written as, I will write here C2 as CP CQ upon CP plus CQ plus CR. So this will be my final result. So first of all we have to calculate what is the value of CP, what is the value of CQ and the value of CR. Here the CP will be equals to, here the CP will be equals to epsilon 1 S by 2, because here the plate area will become S by 2 here and the separation between the plates will be D by 2. So this will be D by 2. I can write it as epsilon 1 S upon D. This is our relative permittivity. So I have to make it multiplied by epsilon 0 also here. So this will be equal, this will becomes epsilon 0 epsilon 1 S by D, and I can write it as epsilon 1 value is 2, so 2 epsilon 0 S by D. This is my value of Cp. Now the value of Cq will be equals to the value of Cq here. This will be again epsilon 0 epsilon 2 S by 2 divided by D by 2. So if I will calculate the value of the Cq, this will becomes 4 epsilon 0 S by D. Okay, so these are the value of Cp and Cq. Now I have to omit this diagram from here, and I have to calculate the value of Cr also. The Cr value will be equals to, in the value of Cr we have seen that the dielectric constant was epsilon 1, relative dielectric constant was epsilon 1, and the area between the plates was S by 2, area of the plates was S by 2, and the separation was D. So this will becomes equals to 2 epsilon 1 was 2 epsilon 0 S by 2 multiplied by D. This will be cancelled out. So we have finally the value of Cp, Cq and Cr, and if we will put this value, then we will find out the value of C2. So let us put the values of Cp, Cq and Cr to find the value of C2. So the value of Cp is equal to 2 epsilon 0 S by D multiplied by Cq, that is equals to 4 epsilon 0 S by D divided by Cp plus Cq. So this will be equals to 2 epsilon 0 S by D plus 4 epsilon 0 S by D multiplied by plus Cr. So I will put the value of Cr here, and the value of Cr is epsilon 0 S by D. So let us find the value of C2. This will be equals to 8, and here this will be equals to 6, and epsilon 0 S by D I can directly solve it, and epsilon 0 S by D, and finally if we will solve this value, this will be equals to 8 by 6, here it will be 6 by 6, so it can be written as 14 by 6 epsilon 0 S by D. So here we find the value of C1, that is the first case, and we find the value of C2, that is 14 by 6 epsilon 0 S by D. If we will divide it by 2, it will be 7 by 3. If we will check the question, we have to find the value of C2 by C1. So if I will find the value of C2 by C1, I can directly put the value, that is C2 by C1 will be equals to 7 by 3. So what is my answer? C2 by C1 will be equals to 7 by 3. So this is my answer. Thank you. Good morning students. We will discuss question number 10, paper 2, code 5. First, I will just read the question. An ideal monoatomic gas is confined in a horizontal cylinder by a spring-loaded piston as shown in the figure. Initially, the gas is at temperature T1, pressure P1 and volume V1. The spring is in relaxed state. The gas is then heated very slowly to temperature T2, pressure P2 and volume V2. During this process, the piston moves out by the distance x. Ignoring the friction between the piston and the cylinder, we have to check the correct statements A, B, C and D. Okay, so first of all we will check the statement A. Let us discuss the diagram first. There is an ideal monoatomic gas in the closed chamber. Here there is a spring is connected. Initially it is in relaxed position. Outside pressure is P0. Initially it is in relaxed position. The pressure or the volume and the temperature are P1, V1 and T1. Finally we are heating up this gas very slowly, and the final conditions become P2, V2 and T2. And in the case A, in the option A, we have to calculate the energy stored in a spring is equals to 1 by 4 P1 V1. We have to check it is correct or incorrect. What has been given to us? V2 is equal to twice of V1 and T2 is equal to thrice of T1. These are the conditions, final conditions. Number of moles will be conserved in initial case and the final case. So the number of moles initially was P1 V1 upon T1 and the finally it is P2 V2 upon T2. So I can find out the value of P2 also. So the value of P2 in the terms of P1 will be equals to P1 V1 T1 multiplied by T2 upon V2. Okay. So the value of P2 will equals to P1 V1 upon T1 multiplied by the value of T2 has been given as thrice of T1 and the value of V2 has been given as twice of V1. So P2 can be written as, we will cancel out V1 to V1 and T1 to T1. So the P2 will be equals to 3 by 2 P1. The first case. Okay. Now I will apply the condition of equilibrium to the piston in initial case and the final case. In the initial case, the condition of equilibrium, I have to omit the upper side here. Okay. In the initial case, initially equilibrium state of piston will define us that the pressure from the gas is P1. So the force exerted by the gas is P1A to the piston from the left side to the right side, and the pressure outside is P0. So the force exerted by the outside surrounding is P0A. So we can write that P1 is equal to P0. Now the final case, finally equilibrium state of piston will be equals to, the pressure inside becomes P2. So the force is equal to P2A and the force from outside is P0A, that is by the surrounding, and the spring has been displaced by a distance of x. So the force restored in the spring, that is called spring force, will be equals to kx. Okay. So I can write here the value of kx can be P2 minus P0 multiplied by A, but I know that the value of P0 is equal to, the value of P0 is equal to P1. So the value of kx becomes equals to P2 minus P0, or I can write it as P1 because P0 is equal to P1. So P2 minus P1 into A. So this is value of kx. If I want to calculate the value of x, what the distance displaced by the piston in the terms of volume. So the change in volume is V2 minus V1 divided by the area of the piston. So this is the distance displaced by the piston. So this is x, this is spring force, and I have already calculated the value of P2, that is equals to 3 by 2 P1. So we are having all three conditions. Now I have to calculate the energy stored in the spring. Energy stored in a spring, we know that the value of energy stored is half kx square. I can write it as half kx multiplied by x. Half, the value of kx is already known to us now, P2 minus P1 multiplied by A, and the value of x is V2 minus V1 upon A. So this is equals to P2 minus P1. We will cancel out A to A here, and energy in terms of P1 and V1 we have to check, and whether it is 1 by 4 P1 and V1. So 1 by 2, if I will subtract P1 from P2, I can directly write it as 1 by 2 P1, and V2 minus V1 is given in the case V2 minus V1 will be equals to V1, because the value of V2 is twice of V1 minus V1. So this will be equals to V1. So the answer will be equals to 1 by 4 P1 into V1. So the option A is correct. Now we will check the option B. So we have already calculated, we have checked the option A. Now we have to calculate the option B. For the option B, we have been given that V2 is equal to twice of P1 and T2 has been given as thrice of T1. These are the same conditions as given earlier in the case A. So as we have already calculated, the P2 will be equals to thrice of 2 T1. Now we have to calculate what is the change in internal energy. And as we know that the change in internal energy is equal to 3 by 2 nR T2 minus T1. I have put here 3 because it is ideal monoatomic gas and we know that the degree of freedom will be equals to 3. So I have directly used the formula 3 by 2 nR T2 minus T1. Okay. Now I have to check whether the value of change in internal energy is equal to thrice of P1 V1 or not. So I have to change the value of T2 and T1 in the terms of P1 and V1. So what should I do here? I can write it as 3 by 2 nR T2 can be written as P2 V2 and nR T1 can be written as P1 V1. So let us move ahead. 3 by 2 P2 can be written as 3 by 2 P1, V2 can be written as twice of V1 minus P1 V1. So if I will check it, delta U, it can be equals to, I will cancel 2 to 2. So 3 P1 V1 minus P1 V1 can be written as twice of P1 V1, and this will be equals to thrice P1 into V1. So again the option B is correct. Now, and we will check the option C. So here I can just summarize here that option A is correct as of now, option B is correct. Now we have to check option C and option D. In the option C, the parameters of V2 and T2 is changed. So V2 is now thrice of P1, T2 is now 4 times of T1, and we have to check the work done by the gas, whether it is 7 by 3 P1 or not. So what is my steps initially? First of all, I will check the P2 in terms of P1. I can write it as P1 V1 upon T1 multiplied by T2 upon V2. Okay, so the value of P2 here will becomes P1 V1 upon T1. The value of T2 is equal to 4 times of T1. V2 can be written as 3 times of V1. So I can write it as 4 by 3 times of P1. So this is my value of P2. So I will just omit it because we will be having very less space here. So I have calculated P2 and I can write it as here P2 is equal to 4 by 3 P1. Okay. Now I have to calculate the work done by the gas. Work done by the gas. According to work energy theorem, as there is no friction in this particular system, so energy will be conserved. So we can apply a work energy theorem. So work done by the gas is stored somewhere in the system only. So work done by the gas is stored in the spring and is consumed also when we do the work against the external force. So work done by the gas can be written as work done against external pressure, external force and spring potential energy, because a few part of the energy has been stored in the terms of potential energy in the spring. So work done against external force, work done against external force is equal to, I am just writing the magnitude here, so work done against external force is P naught A multiplied by X, because P naught A is the external force and we have done work done against external force when the spring or the piston is displaced by X, that is force into displacement. So this is P naught A X plus spring potential energy is stored as half kx square. So we have to calculate these values. Okay, let us move now further. This P naught can be written as P1 because initially the P naught was equals to P1. So I can write it as P1. This is A. Okay, and this X can be written as change in volume upon area. Okay, the same way half kx, as we know already, it can be written as half kx into x, because we have to find the answer in the terms of P1 V1. So we are interested to replace this x and k in the terms of P1 V1. So I can write it as P1 V2 minus V1, and this is equals to half kx. Kx already we have calculated it as P2 minus P1 multiplied by A, and the x can be written as V2 minus V1 divided by A. Okay, so what is my final answer? P1 V2 minus V1 plus half P2 minus P1 multiplied by V2 minus V1. Now I have to just put the values and I have to calculate the answer. So work done by the gas can be written as P1 V2 minus V1. P1, the value of V2 is equals to thrice of V1. So thrice of V1 minus V1. So this is my P1 V2 minus V1 plus half. So P2 minus P1 can be written as P2 is equals to 4 by 3 P1 minus P1, and here V2 minus V1 can be written as thrice of V1 minus V1. Okay, so this is my initial first case in case. Okay, so work done by the gas is equals to twice of P1 V1 here, and here I will see here this will be equals to 1 by 3 and this is equals to 2 V1. So this will be cancelled and I can write it as plus 1 by 3 P1 V1. So the answer will be equals to 7 by 3 P1 V1. So let us check. Yes, again the option C is correct. It is 7 by 3 P1 V1. Now we have to check the option D also. Okay, no doubt this is a lengthy question and we have to have a speed to solve such kind of questions. So option D, again we will see here V2 has been given as thrice of V1, T2 has been given as 4 times of T1. The same way, it is again the same conditions. We have to calculate P2. We have already calculated initial case. Again we will check it P1 V1 T1 upon T2 upon V2. If I will put all these value here, I can directly find the value of P2, that is 4 by 3 P1. The same is case in C. Heat supplied to the gas. Now we have to calculate the heat supplied to the gas. Heat supplied to the gas according to the first law of thermodynamics. Okay, Now we'll check option D. In the option D, we have been given as V2 is equal to thrice of P1 and T2 has been given as 4 times of T1. And we have to calculate the heat supplied to the gas. So, first of all, we will find out the value of P2 in the terms of P1. The value of P2 will be equals to P1 V1 upon T1 into T2 upon V2. The value will be equals to 4 by 3 P1. It is the same value as we have checked in the option C. Now we have to see the heat supplied to the gas. The heat supplied to the gas according to the first law of thermodynamics can be written as delta U plus delta W. As we have already calculated the value of work done in the option C, and that was equals to 7 by 3 P1 V1. So I will use the value 7 by 3 P1 V1 here. Now I have to calculate the value of delta U also here. The value of delta U can be written as P2 V2 minus P1 V1, okay, divided by 3 by 2, okay, multiplied by 3 by 2. What is this value delta U? Let me explain here. That can be written as F by 2 NR T2 minus T1, okay. The value of F is 3, so 3 by 2 NR T2 can be written as P2 V2 minus P1 V1. So I have just put here 3 by 2 P2 V2 minus P1 V1 upon 2, that is delta U, and this is equal to 7 by 3 P1 V1. So we have to just put here the value of P2 V2 3 by 2. The value of P2 is equal to 4 by 3 P1, okay, multiplied by V2, that is equals to thrice of V1 minus P1 V1, okay, plus 7 by 3 P1 V1. So this 3 is cancelled here. 4 P1 V1 minus P1 V1, this will be equals to thrice of P1 V1 multiplied by 3 by 2. So this will be equals to 9 by 2 P1 V1 plus 7 by 3 P1 V1. I can take the LCM here. The LCM will be equals to 6, okay, and this will be equals to 27 plus 14 multiplied by P1 V1. So answer will be 41 by 6 P1 V1. If you will check the option, it has been given as 17 by 6. So the option D is wrong. So the final answer will be A, B and C. Thank you.